This video is going to be based on the pollution objective sheet, which you can find on Edline. Please download and print out this sheet before you watch this video so that you can fill in the answers as we go along with the PowerPoints. Don't forget, this pollution objective sheet will be due on Monday in class. So I'm just going to go through each of the objectives, and feel free to rewind if you need to in order to get all the information. But this is what your quiz on QuizStar will be based off of. So objective number 1 says to compare and contrast ozone in the stratosphere and the troposphere. Looking at this PowerPoint slide, you can see that we have the good ozone in the stratosphere, and then we have the bad ozone in the troposphere. Make sure you know the chemical formula for ozone, which is O3, and that the ozone in the stratosphere is going to protect us from ultraviolet radiation, and the ozone in the troposphere can cause harmful health effects. It's a respiratory irritant. It can also cause the burning of the eyes, as well as reduce plant growth. So the ozone in the troposphere is harmful, and the ozone in the stratosphere protects us. As you look here, this is showing you the formation of ozone in the troposphere. Again, ozone in the troposphere where we live is a pollutant. It's a respiratory irritant. And as you can see from this picture, which is actually from your textbook, we see our source of the pollutants. The pollutants that are going to contribute to ozone formation in the troposphere are nitric oxide, or just nitrogen oxides in general. You can see some hydrocarbons here, and some carbon dioxide. So we see some reactions that take place in the atmosphere. You don't need to memorize these reactions, but you do need to know that ozone is a secondary pollutant, and that it is one of the main components of photochemical smog. So again, ozone in the troposphere, it's a pollutant. It is a respiratory irritant, and it comes from our automobiles or car exhausts, our nitrogen oxides. We also have hydrocarbons and carbon dioxide, which aid in the formation of ozone in the troposphere. Ozone in the stratosphere, oh, here's your formation, ground level formation. Again, when you see VOCs, volatile organic compounds, this is a type of hydrocarbon. So VOCs are volatile organic compounds. Again, that means that many of them have a low boiling point, and so they will change to a vapor, which can be harmful and enter our atmosphere as a pollutant. So volatile organic compounds are a type of hydrocarbon, category of hydrocarbon. So our ozone in the stratosphere, if you look at this slide, you can see this picture, I believe, is from your textbook as well. We see the formation of ozone in the stratosphere, and we also see the breakdown of ozone. You should know that, and this is for number 2, ozone is broken down every year naturally in the Antarctic springtime. So it's when we have the return of UV light, and it's right after we have that cold air mass, part of the circumpolar vortex. And so this is going to contribute to the breaking down of the ozone layer. So ozone in the stratosphere we have here, like I said, springtime in the Antarctic, which happens to be October-ish. A lot of students will get confused on an exam or a quiz, and they think springtime, but they forget that we have opposite seasons in the southern hemisphere. So here we have the formation of ozone. As you can see, it says O3 is produced by photodissociation of O2. So in order for the ozone to form in the stratosphere, we need sunlight. And we can see that it's going to essentially rip off an oxygen from diatomic oxygen. And we're going to have our molecular oxygen, which is going to combine with an O2 molecule to give us O3. And that's going to contribute to the formation of ozone. Now, during the springtime in the Antarctic, so October, when we have the return of the sunlight, and we also have some chemicals that are released from the troposphere from humans, so anthropogenic chemicals, we can see the breakdown of O3. Some examples, we have chlorofluorocarbons here. We have nitrous oxide or nitrogen dioxide, or nitrous oxide, excuse me, and methyl bromide. Really, we want to focus on the CFCs and the methyl bromide. Again, anytime you see a chlorine atom or a bromine atom, you should think that this may have something to do with the breakdown of the ozone layer. So as these chemicals move up through the atmosphere, you can see the reactions right here. We're going to have chlorine that's going to become chlorine monoxide, and then diatomic oxygen, or just O2. And O2, unfortunately, does not protect us from those harmful UV rays. So O2 is going to be up in our stratosphere, allowing more of that UV light to make its way down to Earth. Chlorofluorocarbons, you need to know where they come from or their source. Remember, one of the major places where they were emitted from, they were used as coolants in air conditioners and in refrigerators. So that's the main place where we've had our CFCs. Also, they were found in aerosol cans. They were used as propellants. They are currently banned in the United States due to the Montreal Protocol. Oops. Methyl bromide is a pesticide, also banned in most developed countries. And this can also be an ozone-depleting chemical. Nitrogen oxides, they play in the breakdown, but they don't directly dissociate O3. Here you have an animation showing you the breakdown of ozone, and it stopped working. There we go. The UV radiation, again, going to knock a chlorine atom off, and then we're going to see oxygen molecules and a free chlorine atom. That one chlorine atom could break down many, many, many ozone molecules. Number 3, says to describe why the ozone in the stratosphere is important to life and how it is broken down. Again, we just went over that. So ozone in the stratosphere is important because it blocks out harmful UV rays. We're going to look at those specific on the next slide. And it protects us from skin cancer and cataracts. Okay, so looking at number 4. What are the three types of UV radiation? We have UVA, you can see, UVB, and UVC. The ozone plays a crucial role in filtering out all of our UVC rays. We see some UVB rays making their way down to the troposphere, and UVA rays make all of them, according to this, make their way all the way down to the troposphere. So you should know it blocks out those harmful UVC and some UVB rays. And UVC and UVB, they are more harmful. They have more energy than the UVA rays. All right, let's look at radon. Radon is a naturally occurring gas. It is formed from the decaying of uranium, so U-238, and it originates from our bedrock, so from underneath the ground. We have radon that seeps up into our homes. You can see from this picture, from the bedrock, goes into our water wells. If you have well water, can go into your basements, into the cracks of your home, and eventually enter your home. The problem with radon is that radon can cause lung cancer. So if you have these radon particles, you're breathing them in, these are alpha particles that can cause lung cancer. If you look at my map here, you can see areas that have higher than normal radon levels. So you can see the high is in the dark red/purple, lower is in that yellow area. And so these are the areas where they have higher than normal radon levels in their homes. Again, it causes lung cancer. It's naturally occurring. One of the common mistakes that students make when they're trying to describe radon or explain its source is that it comes from power plants. Really, we're seeing most of the radon entering from the bedrock, from underneath the ground. Number 6, what is acid deposition? You should know that acid deposition is simply acid rain. and how and where does it come from, or what does it form, and what are some consequences. So really important to understand, this is a picture again from your textbook, that acid rain many times originates from our sulfur oxides and nitrogen oxides. So sulfur dioxide, you can see nitrogen oxide here, and acid rain, so nitric acid, nitrous acid, sulfuric acid, these are all examples of secondary pollutants. And we have here our primary, sulfur dioxide and nitric oxide. These are our primary pollutants. So sulfur, you should know, comes from the combustion of coal. So as we are burning our coal to produce electricity, we have high amounts of sulfur. Nitrogen oxides come from cars. So both of these come from the combustion of fossil fuels. Cars, we're talking about oil. Coal is a fossil fuel. And so this is moving up into our atmosphere, can be combining with water, and then it's converting into acids. When it rains, we have some of this acidic water or precipitation that goes off into our lakes, rivers, and streams, can also enter onto our land, run off into our waterways. And some of the consequence associated with this is that it could decrease the pH of lakes, therefore killing aquatic organisms. Many aquatic organisms can only survive within a narrow range for pH. It can also damage buildings, so it could have an economic bearing on us. So it could damage some, national monuments that would need to be refurbished more often. Number 7. Oh, here we have some more about acid rain. Again, I think we talked about this in our soil chapter, but we have this acid rain. It can also harm not only aquatic organisms, but our trees and our plants. So it damages the leaves, can reduce photosynthesis. And so we can have just the death of a tree because of the acid rain. Sometimes it causes the release of certain minerals like aluminum, and aluminum now can be taken up by this tree or this plant and toxic levels, and therefore killing the tree or the plant. Some ways that we can reduce acid rain. Notice that this is a wet scrubber we have here. Again, this helps sulfur to settle out. So this would be used in a coal-fired power plant, can help sulfur settle out, and then we would end up with a sulfur sludge that we would have to dispose of elsewhere. But this is an air pollution control device that would help to reduce the amount of sulfur entering the atmosphere, therefore reducing acid rain. Okay, so for number 7, if you could do me a favor and cross out, it says name the greenhouse gases listed in the Kyoto Protocol. You have them listed here. It's a good idea to know what they are, but it's really important that you just know the main greenhouse gases. And so here we have some of the main greenhouse gases. Don't forget that water vapor is the #1 greenhouse gas in the atmosphere, and it is non-anthropogenic. So water vapor is a greenhouse gas. Some other important greenhouse gases you can see: carbon dioxide. This is the #1 anthropogenic greenhouse gas, so humans are going to put this into the atmosphere. We have methane. Methane can originate from the flatulence of cows. Methane is the main component of natural gas. We have nitrous oxide. Again, our nitrogen oxides, a lot of them originate from the combustion of gasoline, so from cars. We have our CFCs. You look at this chemical formula right here. These are man-made, so they're all anthropogenic. They're not found naturally. You can also memorize HCFCs, hydrochlorofluorocarbons, but it's not as important. O3 is not on here, but O3 is also a major greenhouse gas. So O3, is a secondary pollutant, and we talked about the formation of O3 in the troposphere a couple slides ago. Here we have our annual greenhouse gas emissions. And you can see carbon dioxide versus methane, nitrous oxide, and you can see where they come from. You should know that a lot of our air pollutants originate from transportation, and then we have our industries. All right, eutrophication for number 8. Looking at this picture, this is also from your textbook, we are comparing eutrophication or eutrophic lake and an oligotrophic lake. Don't forget that eutrophication occurs from the addition of plant nutrients. So a lot of times we see this, and we talked about the dead zone in the Gulf of Mexico, but we'll see this when we have phosphates and nitrates runoff from farmland. Many times it will go into rivers or lakes, as you can see here, and it's going to increase the algae, so it's called an algae bloom, and it's going to reduce light penetration, as you can see right here. We have decomposers that are rapidly breaking down the algae, and they are using up the oxygen in the water, making it hypoxic. And hypoxic, don't forget, means that the water doesn't have oxygen. So when we have low dissolved oxygen, just to remind you, that means that we have a high biological oxygen demand. And biological oxygen demand is the amount of oxygen needed for anaerobic organisms to break down organic matter. So as you're looking at this, we see again, eutrophication occurs from nitrogen and phosphorus, causes the algae bloom, and eventually we can have the death of fish and other aquatic organisms. Compared to our oligotrophic lake, oligotrophic is clean, clear, pristine, lots of light penetration, low nutrients. Again, when we're talking about nutrients, we're talking about phosphate and nitrate, or plant nutrients. And so you can see the main cause here would be the runoff from agricultural land from fertilizers. Our disposal of solid waste, we just went over this, so this should be fresh in your mind. Don't forget that I think your book said 54, but even more updated, 55% of our solid waste is disposed of in a landfill. You can see that 30% is recycled, and we're looking at just over 14% that's burned or incinerated. So important percentages to know. The main reason why the sea level, number 10, the sea level has risen according to scientists over the past 100 years. I said this in class, a lot of students want to say because of the melting of the glaciers and the ice caps. The number one reason, or the main reason here, you can see is due to thermal expansion. And so you can see that according to this graph here, that from 1900 to, I don't know, 2010 here, we're seeing the increase in the sea level. The sea level is rising. Thermal expansion, this is just showing kind of how thermal expansion happens. As a substance is heated, it is going to expand. So this is the main reason why we see the sea level rising. Okay, so for your next objective, it says to, number 11, differentiate between point source pollution and non-point source pollution. Just don't forget, point source pollution, I know there's not a slide for it, but point source pollution comes from a specific place. So an example would be like a cruise ship that's releasing untreated sewage into the water. It could be a pipe from an industry. That water is called effluent or effluent, which is leaving that industry or that building. And point source pollution is easy to control legislatively. We can find someone or a company and say you cannot legally pollute. Non-point source pollution, it's very difficult to tell where the pollution is coming from. The best example of this is agricultural runoff. So for your next objective, number 12, I want you to change the objective to say name 2 alternatives to chlorine for purification of water. So purification. And if you look here, we have our water treatment, and this was part of chapter, I want to say 22, and you can see water purification. Maybe it was 14. But here we have our water that's going to be used for drinking water. It's going to go to households. It could be from a lake, or it could be from the aquifers, and it says at first we're going to collect this water. It's going to go to a water treatment plant here, at that water treatment plant. It's going to go through a series of screens and filters. We're going to add aluminum sulfate to coagulate any solid materials, and then it will be filtered, so it's going to help clump together solid materials, filtered out. And then in the United States, we use chlorine, and we know that chlorine is added to our water, and even some chlorine's left in our water as it makes its way to our homes and offices and schools, and then after that it leaves and goes to a sewage treatment plant. So we're really talking about this area right here. What happens for purification? So like I said, in the United States, we use chlorine to purify our water. There are some negatives associated with chlorine. It has been linked to different types of cancers, such as cancer of the liver, pancreas, but we saw in some areas where they stopped chlorinating their water, you can have an outbreak of waterborne diseases. Other countries, other areas, they don't use chlorine. Instead, they use either ozone, so O3, what we've been talking about, or UV light. They also work as a disinfectant, and they kill pathogens. Europe uses mostly ozone, so O3. And O3 is very unstable, so it will give up an oxygen, and it will be toxic to pathogens and microorganisms. UV light also can destroy and kill pathogens, and so either one of those can be used as an alternative. The only problem with this is that I told you that chlorine is left in the water, so as it's on its way to your house, it can kill any microorganisms, maybe in old leaky pipes, and then it comes to your house, and it should hopefully not taste like chlorine, but will have some chlorine in it. So the only issue with UV and ozone is that there's nothing left in the water to kill any of those pathogens on its way to your home. So sometimes they have to use a chloramine or another type of compound to kill off microorganisms as it leaves the plant. All right. Name positives and negatives of incinerating garbage. And I'm just going to tell you these since there's no slide. But the positives, we're going to see, and we just talked about this, so this should be simple. Some positives is that it decreases the volume of garbage by 90%. And that garbage can be used for energy, so we see waste to energy. So we can use that excess heat to produce electricity or to heat homes, and it produces less carbon dioxide than conventional fossil fuels. Some negatives, we talked about air pollution. No matter when you're burning, no matter what it is, you're going to see some carbon dioxide released, and whatever you're burning, if it happens to have mercury in it or if it has some heavy metals, all of that will go up into the atmosphere, and it could possibly bioaccumulate in our aquatic organisms, and then we end up eating it. We saw the NIMBY. Site selection can be controversial, so NIMBY, again, not in my backyard. Many times there's a lot of opposition or backlash to an incinerator being built in a town. So those are some positives and negatives. If you're looking at the next number 14, be able to give some examples of positive and negative feedback. We've done a lot of these, but just know that anytime that we are going to maintain homeostasis, something's going to stay the same, whether it's temperature, like I said, pH of your blood or light, whatever it is, something's going to stay the same. That's going to be a negative feedback. When something is intensified, when you see that the temperature is getting warmer and warmer and warmer, or population is a great example, human population of a positive feedback, we're intensifying, we're growing more and more and more, that's going to be your positive feedback. All right, so this number 15, I believe, is the PowerPoint I have up here now. It says describe the greenhouse effect and the type of radiation greenhouse gases absorb. So you can see here, this is just showing you the greenhouse effect. We have radiant energy that is making its way down to Earth. We know that if we have a dark surface, it's going to absorb more of that radiant energy. If we have a lighter surface, it's going to reflect. Make sure you remember your albedo definition. So as the Earth absorbs that heat, a lot of that infrared radiation is radiated off of Earth's surface, and it can be absorbed by greenhouse gases such as carbon dioxide, methane, the ones that we talked about a couple slides ago. And so infrared radiation is a type of radiation, it's heat, that is trapped by our greenhouse gases. And if you look here, this is to show you our electromagnetic spectrum, and we're infrared right here, and we have our visible light and UV. So don't get our infrared and UV confused. Infrared radiation's heat, UV, this is harmful to us because it can cause skin cancer and cataracts, and this is mostly blocked out by the ozone layer in the stratosphere. Okay, we're looking at a temperature anomaly, approximate rise in temperature you can see here. Currently it's closer to 0.85, I think I already told you this, degrees Celsius for our past 100 years, but on old AP exams it was closer to 0.5 degrees Celsius. So make sure you have an idea of how much the temperature has risen on Earth. A lot of students think it's a lot higher than that it's risen a lot more. Nope, it's not. It's only about 0.85. And lastly, noise pollution. So I think that we briefly talked about noise pollution. What are some of the side effects? Well, noise pollution, any loud noise, anything that is physiologically harmful to you, it can actually harm your hearing. Many times loud noises, they can destroy destroy your little cilia that you have in your cochlea. So these little hair-like structures, they can basically nerve cells, they're unable to regenerate, and so it can cause you to have permanent hearing loss, and it can lead to you being deaf. Here are the other slides associated with the, I guess, the objectives that I didn't do. Again, we're going back, this was for number 11 for point and non-point source pollution. Again, great examples here, factory, effluent, I think I even said the cruise ship, point source. Anytime that we have, we can actually identify where the pollution is coming from. Agricultural runoff, we can't really tell where the nitrogen and phosphorus is coming from. It's difficult to control legislatively. And just some more information on your air pollutants. So we have particulate matter. A lot of it comes from like the burning of fossil fuels, some problems with it, what we can use in order to reduce it. We have nitrogen oxides, again, car exhaust, it leads to acidification of lakes, formation of ozone, equation for acid formation, and then also you can see the reduction, we can use catalytic converters in our cars. Sulfur oxides, we said burning from coal, contributes to acid deposition. We can use scrubbers. Carbon oxides, we have carbon monoxide and carbon dioxide. Here you have some health effects and what we can do to reduce that. Ozone, here's your formation, again a respiratory irritant, and we can reduce our nitrogen oxides and volatile organic compounds. And that is it. Have a good day.